Hi, this talk is about the UVIT observations of star formation in nearby interacting and merging galaxies that I have been doing with some students and postdocs at the Indian Institute of Astrophysics in Bangalore. I'll start my talk with a brief outline about star formation in galaxy mergers and the importance of having nuclei coming together. Then I will discuss three projects. The first is about star formation in a triple AGN system. The second is the star formation and possible AGN feedback signatures in Markarian 212, which is a dual AGN system. And at the end, I will talk about the discovery of UV emission from a very diffuse galaxy, which is in our close neighborhood. So the main contributors are listed here. The first person, Jyoti Yadav, is a PhD student at the Indian Institute of Astrophysics, and Rubinur Khatun is a postdoc at NCRA. Now, galaxy mergers produce huge amounts of perturbations in the gravitational potentials of galaxies, and these gravitational perturbations cause cloud collisions. Cloud collisions lead to gas shocking, and the gas cools, fragments, and forms stars. This is the big scenario. Hence, it is necessary to see star formation in merging interacting galaxies to detect the presence of gas, because gas or wet mergers, as they are called in the literature, lead to star formation in interacting merging galaxies. In this image here on the right, there are two examples. Both are taken with the UVIT. The top one is a merging pair of galaxies 7733 and 34, and the bottom one is NGC 646, which has a really extended tidal arm extending out to the emerging minor galaxy. And we see in the arm that is extended towards us a number of beautiful knots of star formation. This is something which will be clearly seen in the slides which I'll present later. Now, when the galaxy mergers happen, then the nuclei come closer and closer together, and the nuclei are represented as bulges, and they are like bright pinpoints in the images. And these nuclei will finally be surrounded by a diffuse region or envelope, and in that case, it's called a merger remnant. Now, the nature of the nuclei can be different. They can be both AGN, in which case it's called a dual or binary AGN system. Otherwise, they could be starburst pairs, or they could be starburst AGN pairs. But whatever their nature, usually we find that if it's a wet merger, there will be star formation associated with the nuclei, not just the spiral arms. Now, another effect of star formation in galaxy mergers, which is often not written about, is the feedback. AGN feedback is well known. There is a large amount of hot gas which is driven out from the nuclei during the merging process. This AGN feedback can trigger star formation in the outer parts of the galaxies, but we can also have very powerful starburst winds which will also do this. There can also be a positive AGN feedback, which is basically the fallback of the gas onto the disks, which again will result in star formation. And all of this we can detect with the UV. Now, why UV observations? Now, UV is really powerful because it traces star formation for periods longer than H alpha. And this is why it makes it such a powerful tool to detect star formation in low luminosity or low stellar environments. We also see UV coming from the nuclei. It comes the UV emission arises from the accretion disk around the supermassive black holes. So when we look at galaxies, star-forming galaxies, we can both detect the compact, bright nuclei in UV as well as the star formation associated with the merging process. Now, we've been using the UVIT in our studies, and the UVIT has a resolution better than GALEX, and that's why it makes it more powerful. It has a resolution of about 1.2 arc second. It also has a large field of view, which also makes it quite powerful to study the nearby galaxies, because we not only get a good resolution, but we can also get a good field of view. We have been doing UV observations of a sample of interacting galaxies lying in the south, about 10 of them, and we have already got the near infrared images of these galaxies. They are both the minor mergers, as you can see on the left. They are merged already in a common envelope, as you can see in the central image. And finally, in the right one, you can see the galaxies coming closer and closer together, interacting, but not merging. Now, one of our galaxies produced a nice surprising result, and that is the detection of a triple AGN system. This was in NGC 7733, 7734, and the optical image is shown here. You can see a beautiful compact northern knot associated with NGC 7733. This was previously thought to be a star-forming clump. However, when we looked at the Muse images, we found that it had actually in the BPT plot signatures of AGN activity. Now here on the top left, you can see the FUV image done with the UVIT, and you can see beautiful rings of star formation and a star formation tail that is extending into the bottom left-hand corner. That galaxy we could not identify, but it appears to be not just a group of two galaxies, but a group of four, because the one in the north, the northern north, is an AGN, so the system forms a triple AGN, and the one in the bottom may possibly be infalling into this group. So the distances are quite large between the galaxies, 40 and 10 kiloparsecs. However, the system appears to be gravitationally bound, and we found that uh, the, uh, the redshift differences and the tidal arm clearly signify that this is a triple AGN system. The BPT plot also shows that the northern knot is a AGN, and the other two nuclei are Seaford, Seaford2, and the liner nuclei. So we have a triple AGN system. Now, another exciting result that we got from NGC 7733 is the beautiful stream of O3 emission that you can see from the nucleus. This forms an extended narrow line region, and it is associated with the Seaford2 nucleus in the galaxy. So this galaxy has undergone several rounds of star formation, which we could find in the star formation history using the Muse observation. These were Muse archival observations that we used. You can also see very beautiful rings of star formation that are very clear in both the H alpha Muse observations as well as the UVIT observations. Then we also examined the other galaxies, and we found similar rings that you can see very clearly here in the top left image, faint rings of star formation. These are all complexes which we will be able to later identify. 646 is also another extraordinary case of star formation in a merger remnant merging system. Here you can see a long tidal arm and beautiful knots of star formation over here. Some of these might eventually become tidal dwarf galaxies if they have enough gravity to separate. Now we have also been doing UV studies of dual AGN galaxies. We've done both UVIT studies as well as radio. The Markarian 212 is a very good example. Here with the optical studies, we were able to confirm the AGN nature of the two nuclei. Then we compared the optical image and the radio images with the UVIT image. The UVIT image, a 15 kilosecond deep image, shows beautiful knots of star formation along the kiloparsec scale arm. And you can also see two knots of star formation, which are denoted by numbers 4 and 3 in this image. These knots of star formation are actually A and B in the VLA radio image here. So there is a possibility that the star formation that we are seeing in the knots A and B is arising from radio jet triggered star formation. So this could be an example of kiloparsec triggered AGN feedback. So this is why the FUV observations of Markarian 212 are so distinct, so important. We may be seeing AGN feedback on kiloparsec scales. Now, I would like to end by discussing the discovery of a new diffuse galaxy just around 40 kiloparsecs away, and UV emission was very instrumental in the discovery of this diffuse low luminosity galaxy. Now, when we looked at one of our galaxies, which was supposed to be an interacting galaxy, and it is shown here in the bottom right, we thought that it had a tidal tail. But when we looked at the image in UV, we found that the tidal tail was very extended and did not look like emission from a tidal tail. When we looked at the decals image, we found a kind of a ghost-like appearance associated with this tidal tail, which indicated that this was possibly a foreground galaxy. So this was very important because it shows that the ultra diffuse galaxies, LSP galaxies, which have very diffuse disks, if they are triggered into star formation, they may also appear in the UV. We detected H1 in this galaxy, which we have named as UVIT J2022. And we have also studied using MUSE, its velocity field, which is just represents a rotating disk of 20 kilometers per second. So in summary, I'd like to like you all to take home the message that UV is an excellent tracer of star formation, mainly because it traces star formation for much longer periods than H alpha. So it can detect fainter star formation. A good example being the extended UV disks of galaxies and the faint tidal arms associated with galaxies. When UVIT is combined with IFU observations such as MUNGA or MUSE, then it is an excellent tracer on kiloparsec scales of the star formation in galaxies. Radio continuum is important to understand the association with the nuclear activity, and deep H1 and CO observations are very important for estimation of star formation efficiency. Thank you.